if you don't have ChatGPT 4, and you don't have, here in Hong Kong, it's blocked, or you don't have access, or I don't know, you don't have this in your lab, it will do everything for you. So you can either upload your data set here, you can see file upload, or you can use any of the data in R. So you can have a bunch of things, you know, sometimes when we do demonstrations, we do this with MP. And then you've got like a bunch of examples of how to feed something to ChatGPT. So for example, if you just want to do a box plot based on MPG, so this is what it will feed ChatGPT. Create a box plot, highway versus type, color by type, add jitter points. You submit this, it goes to ChatGPT, gives it this thing, creates that whole thing for you, and then immediately gives you both the R code and the output. So basically, instead of using MPG, just upload your own code. In this case, your simulated Qualtrics randomized thing. Tell it, I want a box plot, and it will automatically do this for you. Now, what's nice about this is that it will also create an Rmarkdown chunk for you, which you can then automatically download afterwards. But let's say you just created your data from Qualtrics and you don't have any idea what did Qualtrics actually do. I want to see the data. So you can explore. How can you explore? So you've got this tab called EDA. You go here and it will automatically give you all of the variables that are there, every possible thing about minimum, maximum, mean, and all that. Has a summary of all the variables. You can even like create a nice table that you can then feed into everything else. Categorical, numerical, correlation, you know, look at all the correlations between all the variables that. And then finally, you can even have like a report. So you can download everything to Rmarkdown. You can either decide if we have more than one chunk. We just created one chunk, but let's create like a bunch of other chunks. So for example, normality. Is city normally distributed? Let's see this. So now we've got chunk 1 and chunk 2. And then in the report, you can decide if you want to do like chunk 1, chunk 2, or all the chunks. And then you just download this into Rmarkdown. And it gives you all of this. And then you copy paste, and then you have everything. 2 seconds, 5 clicks, you've got everything mastered. Do you know how much time it took us 10 years ago to do this kind of stuff? Like you said, book down, go, find some manual, then try, doesn't work, then describe, then debug, then everything done for you in 5 seconds. Yeah? This is just one tool. This is the one that I like the most because it's very intuitive, just got everything there for you. But there's just so many other tools. So this is a new era. The revolution that has happened in the past year, there's nothing like it in the history of science. So you can focus on the real questions rather than struggling with R code. There's really no reason for you to struggle with R code, especially now because it's like simple language. You can just like write whatever your question is. You can just like write it here, type it. It goes to ChatGPT, it gives you everything, and all this for free within seconds. Everything exported to Rmarkdown, everything reproducible, everything done for you. Any questions about this very simple and powerful tool? Yeah, useful, helpful? Yeah? Good, happy I can help you with this. Anytime you're struggling with something in regards to what we do in this course, you're probably doing something wrong. Just ask me, I'll clarify this for you. Everything that we do, we can do simpler and better. Just need to kind of share experiences, look at what others are doing. If there's something that's taking you too long, if you can't find information, if there's something that you're stuck with, you just have to ask me. I'll clarify this for you. There's probably a very quick way for you to solve things, especially when it comes to code. So for today, the topic that we have is researcher biases, how we do biases. And the reason why I'm doing, it's like a two session hackathon kind of thing. We'll do a little bit this week and a little bit next week, is because by the end of this week, you're submitting your stage 1 replication register report. And then each team will be assigned to review somebody else's manuscript and give them some feedback. So all of you will receive and give feedback from others. And there's an art to doing peer review well. Because this is science and we really care about accuracy, having somebody else go over your manuscript, your code, everything that you do, your Qualtrics, is a humbling experience. And sometimes we have all sorts of biases that come into play when we see somebody else's work. We also have all sorts of biases that come into play when we receive feedback. So I don't know how many of you have had this experience of receiving feedback from a journal and reviewers, but immediately, almost every time when there's something even a little bit negative, immediately I get heated up about, I want to send now a text, an email, a Twitter to tell everybody how they're wrong and I am right. Of course, I go and I sleep on this for 2 days. I don't touch it. And then I come back to it and I'm like, okay, they're right. Like there's something here. I need to address this. So I was thinking, like, what's the best way to train you to do peer review well, or to think about this and prepare you for the possibility of you receiving peer review over your own manuscript. So you'll receive this from a different group. Receive this maybe from me and Christy, depending on our availability and time. We'll do our best. Definitely, if we submit this, when we submit this to peer community, we'll get some feedback from them. So how to prepare you for that? How to prepare you to give feedback if you become reviewers? So I wrote a message on Slack asking you to share. I think 2 of you gave me some examples. I was trying to see how to incorporate this. And finally, I decided perhaps the best way is to just show you some of my experiences for you to try and make sense of what's happening there. So this session, we're actually going to start with a hackathon. For each team, I've assigned one peer review that I received. This is a real peer review that I received on a real manuscript, some of it published, some of it not published. And I want you all to analyze those. I want you to read those, take your time reading those, discuss those in your teams, and try to assess what is going on in this peer review. So if we go to this thing, this is the hackathon link. So it's mgto.org, 6010, week 10. We're week 9, but the link is week 10. I'll open this after all of you have either scanned this or went on the link. So for each of you, there's a Dropbox link that links to one of the reviews. I did not put the whole review because I don't want you to get lost. I kind of tried to focus on the thing that I want you to kind of analyze the most. I know that you don't understand which article this is. You don't know what the context is. You don't know what this is about. But I want you to try and read the peer review and try and gain some insights from that. The first analysis that I want you to do in your team is to address cognitive biases that have to do with the way peer review is being given. Is this really objective? Is this really scientific? Or is there something that's problematic about this peer review? So I gave you some examples. For example, is there a publication bias? Is there an aversion to null findings? Is there hindsight bias? Not surprising at all. Everything that you said is not surprising. Is there outcome bias? If negative or positive actually influence the way that this is assessed? Is there maybe prejudice, stereotyping? Is there an halo effect, like something about prestige or reputation? Is there a confirmation bias where somebody is only trying to confirm what it is that they already believe? Is there something about self-interest, me, rather than helping others? Better than average bias, I'm better than you, therefore I will tell you what to do. Is there something like personal comments, personal attacks, or not? Some of these get a little bit personal, and some of these just like very, very professional and clean. So I would ask you to write your bias name, a very brief explanation about what you think this bias represents here, copy paste the example from the Dropbox, and then in a few words, just say, what would be a way to overcome this bias? So spend some time kind of analyzing this together. And then the final question is about, I want you to assess the quality of this peer review. What is good about this? What would you keep? What is the good thing for you to do when you give peer review? And what is bad about this to avoid, to not do when you give peer review? And finally, general impressions. Is this justified, not justified? So even though some of these cognitive biases, this is very experienced journal editors, very experienced journal peer reviewers. So they've been doing this for a very long time. So maybe despite the cognitive biases, maybe there's a value in this. So I want your judgment. Is this valuable, not valuable? Is this good or bad? Is everything clear? Yeah, all good? All right, you're pretty much with your teams, right? Yeah? Okay. So just make sure that you can open the links. So for each team, there's like a link on the top for the Dropbox. Make sure that opens well. I don't think there's any problems with load there. Yeah. And once you're ready, you can begin. We'll do this for about half an hour. We'll check how you're doing. So I would say 10 minutes to kind of read and discuss this amongst yourself, 10 minutes to kind of analyze this, and 10 minutes to summarize the whole thing. Okay? All right, so go for it, half an hour. Okay, so what I suggest now is that we go through some of the case studies. I'll ask you for like your reflections. And maybe to summarize things a bit, I can give you a bit of an anecdote to what the context is. So Team Purple, who is Team Purple? You're Purple? Okay. Can you share a little bit about what was the review? Can you give us some context about this? Would you mind? Can you tell us a little bit?
Yeah, this study focuses on well-established effect named sunk cost effects in
Sunk cost effect
economy and decision making. And the overall view of the editor and the reviewer is that even though this registered replication report did a well job, but they consider whether this replication did a real contribution.
Okay, good. So what were your impressions about the review that you read? What kind of things did you notice? Good, bad? What's your overall impression?
I think overall the reviewer is not being mean, at least. So
it's
not being mean.
Not being mean, okay.
Overall, like it's kind of like talking about some objective reasons. So, like the replication didn't really explain why the replication failed. So maybe the reverse thinks it's better if you can provide some explanation for why the replication fails. And I think that's kind of reasonable. But also another thing is that the reviewer mentions a lot of good things about the paper and also seems to recognize the importance of replication.
Okay.
But then it seems that this didn't really affect the decision. Just saying there to be nice, and then it doesn't really take into account for his decision.
We have a name for this. It's called a compliment sandwich. Good, 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 bad, good, good, good. And then the bad is actually what is it that they want to say, right? So whenever you want to criticize somebody, say some good things at the beginning, it's like, this is worthy, but then like really nail it. And then at the end, just like calm things down a bit, right? So that was your impression, more or less? Okay. Anything else that you want to... How about I give you some context? So just so you understand what went on with this manuscript. So the story with this manuscript, it's a replication registry reports that we did with peer community in registry report of a classic paper by Dilip Soman in 2001. In peer community in registry report, we went through very rigorous peer review, including Dilip Soman, who was very enthusiastic about this. He recommended both stage 1, and when the stage 2 came out, he said, wonderful, this should be published. And then the community gave us an endorsement, meaning that we can automatically publish this with any of the 30 journals that were with peer community in registry report. So we could have just like went ahead and published this. Endorsed by Chris Chambers, endorsed by Dilip Soman, endorsed by all the community, right? Then to my great surprise, I get an email from a prominent journal, Journal of Experimental Psychology General. The editor contacts me and said, I just received a notification that you got an endorsement from the community. Would you consider publishing with us? And I'm like, wow, I never expected this from peer community. They're willing to publish our paper. So I'm like, yeah, let's go for it. So I submit this to the journal officially, and I expect that the next day it will be automatically published because it's endorsed by the community. Instead, I get a notification sent to peer review. I'm like, wait, what? Sent to peer review? Why? This is already conducted, registered report, stage 1, stage 2, endorsed by the community. And then we receive the feedback, and the feedback is full of outcome bias, hindsight bias. One of the problems was we had one successful replication, one failed replication, and there was no resolution of why this happened that way, but it was a registered report. So in a registered report, it doesn't matter what the outcome is. Whatever the outcome is, even if it's mixed, should be published. And then we send it to Journal of Experimental Psychology Journal. They sent us to another peer review, wasting all these resources, and then we get a rejection based on that. Very polite rejection, but this is not worthy enough theoretical contribution, not good enough, and you did not resolve the different findings, but this is a registered report. So very interesting case study. I posted this on Twitter. We had a whole debate about this, whether it's reasonable or not reasonable for the journal to do this. At the end, the journal can do whatever they do in their own journal. But I think the whole process of what happened here was bad. The result, peer community and registry report kicked out the journal from peer community because of us. So Journal of Experimental Psychology, the journal no longer is affiliated with peer community. That's the end. Very interesting case study. Yeah, good. All right. So moving on to the next one. So I think like context is always interesting. First to see what do I feel about this, and then see the context. Who is Tim Brown? Tim Brown? Okay. Can you tell me a little bit about what you saw? What's the case study about?
We are reading a peer review on a replication paper.
Mm-hmm.
The reviewer is the original author of the original study.
Mm-hmm.
Yeah, so basically, my impression about the review is kind of hostile. Person will be offended by open science practice.
Okay. Can you give us an example just so everybody else can see and understand?
So first of all, the reviewer responds to make a very strong response to 2 points raised by authors of the replication.
Mm-hmm.
And when the authors challenge some experimental procedures, I think it's the instructions, and I feel like the instructions is not very clear.
Mm-hmm.
The reviewer says something like, it is okay for any instruction to generate to a
Mm-hmm.
Yeah, and that's one thing. And the second point is, let me have sorry.
Yeah, no worries.
The second point was when the authors ask a question, the reviewer asks the authors to read an organizational psychology textbook for definitions.
Yeah.
And this kind
So this is a second round review. So we responded to the first review, and the reaction from them is to
go read.
Go read. You don't understand what happened here. If you just read a simple social psychology book, then you'll understand what we all understand.
And the rest of the comments are actually challenging the writing styles and what and feel like asking authors to add things that there are the original author thought was important.
Okay.
That's not really related to the research department.
Okay. Yeah.
So I the impression I have here is the reviewer did not really understand the open science focus. Yeah.
Okay.
Yeah, overall, she's downtoning the whole study. That even though the study works out, it won't be a direct proof of her original study being failed.
Yeah. So just to put this in, thank you. Just to put this into context, that peer review was over a stage 1. There are no results. We're just planning to do a replication of their study. They gave feedback, which was quite interesting. And we responded to that feedback. And this was the second round where they got a little bit personal. Now, just to tell you what replication that is, it has a special context, especially because of today. So this is a group of researchers that we talked about last week in the fraud section. So 2 scholars, Dan Ariely and Francesca Gino, are co-authors on that. And she is the lead author. So she's not Francesca Gino and she's not Dan Ariely, but she's one of 4. And it seemed like she just does not like the idea of us questioning, supposedly questioning her or their work with a replication and trying to set it up so that whatever happens as a result, it would not seem as if this is a replication. Now, I'm saying that this is relevant today. I was trying to explain this to them before, because today on Twitter came out a new project called Many Co-Authors of all the co-authors of Francesca Gino who are very worried that maybe their data is fraud. So what they all did is to map out who collaborated with Francesca Gino, which studies did Francesca Gino actually conduct, and then whether they had access to that data or not. To my great surprise, that was one of the papers mentioned over there. And the bottom line is that all 6 studies were conducted by Francesca Gino, and nobody, including the lead author, ever had any access to the data. An unbelievable story. Now, the sad part of this, to give you an example of what happens in this kind of context. So already 2 very interesting case studies, both of them with peer communities somehow related to this, but something that has to do with lead authors, even not ever seeing the data, just coming from a co-author, that just assuming that everything that they did and everything that they said in 2012 will hold forever, and just being very much against the idea of a replication. So here we have more of a contribution. Is it appropriate for a top journal? And there it's more about, are replications in general appropriate or not? Okay, so already 2 interesting case studies. Let's move on. Team Gray, who's Team Gray? Your team, okay. Can you tell us a little bit about what did you see? What's the case?
I think it's similar to what was said before. Just, it seems like the tone of the review was setting up for, like, they already assumed that, oh, this is not publishable at all. It seems like...
So we're talking about the identifiable victim effect, which we talked about before in class. And it seems like there, it's not a registered report. We actually collected the data. We shared the data, and then she had some concerns over this. So what was her feedback? What was the peer review?
We overall felt like her comments were not really that constructive.
Okay.
It wasn't, like, the aim of the review wasn't to help you improve, or as to, because like one of her sentences was like, I'm saying that it cannot be considered a replication and should not be accepted for publication at all.
Suggested for rejection, right?
Yeah, which we just feel like it's not, like, we don't think her comments justify this sentence. Yeah.
Okay. What were the comments that she was raising? Like, what kind of things? Maybe it's a valid concern.
Oh, that could be a valid concern.
Maybe, I don't know. What did she talk about?
So for example, we talk about the pictures. Yeah, okay.
Pictures, yeah. An image of kids, right? Yeah. What did she say about the image?
She said that
it may lead to the legal action in the future, suing her during the journal article, and etc. But
that we used that image.
Yeah.
She also used it, yeah.
You were quite confused by that.
Yeah, I'm also confused by this. Yeah. Anything else? What's so problematic about using this image aside from being sued for sharing this? What else did you see? Like, what is?
Except the photos were outdated.
Outdated? Anything else?
And like this.
Distorted?
Something about being distorted.
Yeah. Mm-hmm. Yeah. Okay.
Which we just don't.
Yeah, I'll give you.
What's the? I don't know how to say it in English.
What is it?
Pushing it.
Pushing it. Yeah.
Yeah. Like,
Okay.
it's like trying to like pick needles out of a hay.
Okay.
To say that it's not a viable replication.
Yeah. Very interesting.
Are like the definition of a replication is what's happening, but she says this is not a replication.
Yeah. So over there we have a big debate about so what images should have been used. So what happened is that first I should give you some context. I reached out. So Israel is a very small place. I know these researchers. I reached out to them and said, we're planning to do a replication. Should we meet up when I'm in Israel and sit down and talk about this? And we did. I went and I met them and we talked about this and everything was like very friendly. And then I asked them to share the images and the stimuli, and they did. And they said, but it's during the pandemic, so all sorts of things are happening there. But they said, we distorted, because these are kids, we distorted the image. So maybe it's not a good idea to distort the images. But we thought about this and we have a dilemma. Should we use new ones or should we use the distorted ones? We asked some other people, does this look distorted to you? They said, no, it looks like normal, so no problem, but maybe you cannot identify the kids that way. I don't know what. So finally, we said, we wrote the entire pre-registration, just like you are, and we sent it to them. We said, we've decided to use the distorted image because it seems to be okay, and this is the entire plan. We're going to go ahead with this. And we got the okay from them. They said, yeah, looks good, support your decision. And then to our great surprise, this review came back. Unbelievable, completely baffling, going against everything that we talked about when we met. I have emails, which I'm responding. I have emails showing that they've actually endorsed this. And we told them that these are the images that we're going to use, and we agreed on all sorts of things. So just responding to this, they have like 20 pages of just showing what the record is. But yeah, very interesting case study. Remains to be seen. But in this specific case, the editor overruled and said, I invite a revise and resubmit despite the author saying that. So also a very interesting case study. There's a lot to learn from that, I think, especially that one about how not to review things. But yeah, that's for you. Yeah, please.
That because it was done during COVID times, that's why it's like doomed to fail. But does that mean like can't do any study during COVID times?
Yeah, exactly. So let me just tell you so we discussed this, and actually the study was conducted in Israel between the years 2000 and 2005. I don't know if you know what's happening in Israel right now, but all sorts of things that happened in Israel just now happened in 2000 and 2005. So this was the second Intifada uprising, buses exploding, restaurants going on, like it was just terror everywhere. That's also unusual circumstances, right? And there was an identifiable victim effect. So just does not make a lot of sense. And we've already discussed some of the evidence on identifiable victim effect is very problematic, and we're trying to sort this out. Thank you. Okay, moving on. Team Orange, who's Team Orange? Yeah, what's the case study? What did you see?
Our case study was on the review on the accentration effect, and we observed similar patterns of response as the previous two themes.
Okay.
Basically, the original author doesn't believe in the concept of replication study, and it was really like they use words that are super passive aggressive,
Like what? Can you give an example?
Where does the confidence come from? And it happens throughout the entire review.
Why would you call this passive aggressive? Like what?
It's
What is?
aggressive, but because it's on the paper and they try to back it up with like scientific rigorous language, which I don't buy them, but like they try to like hide the aggressiveness behind it. But this just occurred throughout the review and it's not constructive at all. So
what are the main points that keep coming up? What's not to believe in a replication? What's the problem?
First of all, the author was questioning if the concept of comprehensive direct replication actually exists. And the same thing happened. He was referring to because the original study was done 30 years ago, and with Trump, Me Too movement, so
things have changed.
Dynamic time changes. Can a replication actually exist? And there was also some outcome bias. He was saying the author of replication study seemed to accept the phenomena existing. So maybe he was just like trying to pointing out some like scenarios that are not applicable, but they were really as readers, do we really think that's meaningful? So basically, like seems to us, he's just missing the whole point of replication, the value behind it.
Did it say if he ever conducted a replication?
He did. That's
okay. What happened then?
Confirmation bias.
Okay, yeah.
So the only scientific evidence he quoted from the field was by himself.
Yeah. Well, what did he say about it?
He was like, if the editor consider publishing this article, you should definitely consider publishing ours. Okay, along with it. Okay?
Yeah, our response to it.
Saying like that replication would yield more power or will more have more credit.
Yeah. What did he do differently than us? Why is his replication better? Yeah. Okay. So I'll tell you another interesting story, another anecdote for you to. Actually, we conducted by now 4 different replications of work by Shafir. 3 out of the 4 replicated. Terrific. No problem. This one, it was a failed replication. Yeah. So 8 scenarios, 2 worked. 6 did not work to the same extent. And there are actually 2 theoretical accounts. One theoretical account was his, and another theoretical account was by somebody else. And we found support for the opposite theoretical account. So we're not talking like random noise. This is not like nothing worked. Things worked according to a pattern that did not support his theoretical view, but a different theoretical view. So it was very interesting to try and see why this happened. In addition, the reason why we started with this replication is because many labs, 40 different labs from around the world tried to replicate 1 out of the 8 and failed. And we found exactly the same thing as many labs. So it's not just like us, but he has a whole problem with the idea of you take things as is and you don't try to change them to the current context. Of course, only for the things that failed, because if you found support for it, then of course it's great, right? And actually, just to put things in context, last week, we received the reply to our published article. So the editor overruled him, published this, and invited him to submit his commentary, which was published. And now we're asked to reply to the reply. So another very interesting case study there. Yeah.
How are you gonna respond to this letter? Because it doesn't really have, like, it doesn't really pinpoint anything specific that like requires your response on like a scientific level.
Good.
But like most of it just like rhetorical question.
Good. So hold that thought. Next week, all of you will receive our reply so that you'll know what is it that happened with this at the end to like resolve the uncertainty. But all of these very interesting case studies. Good. Thanks for like going over things and sharing your impressions. Team Red. Yeah.
We read a review on publication about the regret action effect. And I think our problem is mostly with reviewer 1 because the 2 points that were highlighted out were basically reviewer 1 saying that why should I care? I don't care about the research question.
Yeah, it's not interesting to me.
Yeah.
Why should it be published?
Like,
because it's not what I want to see.
He even said, like, the whole study was very well conducted, well planned, well executed, competently. But then still, it doesn't meet the bar for OPH.
Yeah, this very prestigious journal. Yeah, good. So let me give you some context as well. Some more context. This is the last time I ever submitted to a management journal. So just so you understand, I did my PhD in management, moved completely to psychology, and we had a lot of pressure to publish in top tier journals like OBHTP. It's on that list. So you've got like AMJ, JAP, a bunch of things, and OBHTP. And since then, I've tried many times. I've never published in a management journal because of a lot of these things. What happened there? We had four different studies, four data collections, pre-registered, all of it shared, showing a phenomenon. In this case, it's called the regret action effect. And we submitted this to the journal. And basically the reviewer said, this is just not interesting enough. Or you need to show why this has practical implications. Or you need to show why it would work in all of the context. So the editor, one of the things, I know this editor well. So one of the things that the editor is asking me is for three additional studies, after which he will see if he wants to accept this or maybe he has some new comments. And to me, this was completely unreasonable. I refused to revise. I said, thank you for... So this was a invitation to revise and resubmit. I said, I will not do this. I submitted this to a social psychology journal, which accepted this almost immediately, saying 4 pre-registered studies showing the same phenomena, good stuff. So this is how that came to be. So not as extreme as the other stuff, but still very interesting, because management journals can sometimes, or if you submit to JPSP, or if you submit to some of the big journals, it's like, but please run another study. And then it's like, okay, so please run another study. You haven't done this, and please run another study. And I am not willing. I've decided this was 2018. I've decided I'm not playing this game. So yeah, my last submission to a management journal. Good, thanks for that. Team Green, the last team.
So
Conjunction effect, yes.
it's quite aggressive and judging.
Aggressive? What did you see?
Yes, like she or he, like pretty much was criticizing everything in this report and saying that it was no value of doing a replication of a replication state. And see no theoretical implications of
theoretical implications, no contribution.
So, yeah, we thought it's not very constructive in providing any suggestions to improve this.
Not constructive. Yes, thank you. So just to put this one in perspective, this is a classic one by Kahneman. So there's, I don't know if you're familiar, but in judgment decision making, there's the Kahneman group. And then there's a whole different group from Germany. So the way that Kahneman likes to address these problems is by doing an adversarial collaboration. So Kahneman versus another person from the other camp found a third party to mediate between them. And they both conducted a series of replications of both of their perspectives together in order to try and see whether this is resolved or not. We revisited that in order to see whether 2 decades later this still holds. So the way that they frame this is that we're doing a replication of another replication, but it's not exactly that case because this was an adversarial collaboration trying to bring in 2 perspectives together. It was a little bit difficult to publish this, and then we had to go to like a different journal, which finally accepted this. The case study is called "A Physics Professor Bet Me $10,000 I'm wrong." And we're talking about a physics professor from UCLA, big university in the US, that went on his YouTube channel and told him that he is absolutely wrong. So they decided to do a bet on $10,000. So I'm just going to show you the video. We're just going to like watch this. As we're watching this, I'm asking you to do something very similar to what we just did in the exercise. I want you to try and identify on both sides what kind of biases are there. Who is biased, to what degree, what's happening there, how to overcome this, okay? Cognitive biases, both sides.
I am here to sign a document betting $10,000 that my last video is in fact correct. This is the video in question. Some people may have missed it, but in this car there is no motor, no batteries, no energy source besides the wind itself. And the counterintuitive claim is that this car can maintain speeds faster than the wind that's pushing it. And there is a physics professor at UCLA who got in touch to say that he thought that I was wrong, that the explanation was wrong. You know, we went back and forth a little bit, and eventually I said, well, how about we bet $10,000? I can prove it to you, this vehicle really can go downwind faster than the wind. And to my surprise, he is taking me up on the bet.
Look, no one is perfect, but you have a much lower error rate than most people on YouTube, in YouTube space.
Now, Professor Alex Kosenko wanted this wager and all related discourse to be public. In fact, he suggested we get a celebrity to witness the signing. So I asked Neil deGrasse Tyson, Bill Nye, and Sean Carroll to be our witnesses, and they graciously agreed.
And Alex, I just want to say, I agree with everything you said about Veritasium, that generally I can watch it and not have to wonder, is he going to mess up? How am I going to...
No, he's brilliant. No, he's brilliant.
I'm excited about this bet because if I am wrong, then I want to know. Like, the whole point of the channel is to get to the truth, and that is, I think, why we're all here today, and I think, you know, this is a great chance to sort of see. I'm going to summarize Alex's main points in this video, but I'll put his full presentation here.
So let me first explain what I see in the video. In the video, the vehicle is operated in a gusty wind. Initially, you have the wind speed exceeding the car speed, but then the wind speed is not constant. The wind speed drops, and the car moves by inertia with deceleration for a while.
So basically, Alex thinks a gust pushes the car to a high speed, and then when the wind dies, the car is going faster than the wind momentarily, but it must be slowing down.
In fact, that will be my conclusion at the end of this presentation, that whenever you have velocity faster than the wind, I'll actually show you in an equation, the acceleration is negative. Okay? The second effect is that the wind in the video is measured at the height of about a meter or meter and a half, but the propeller goes to some 3 meters above the ground.
Now, due to interactions with the ground, there is a wind gradient. Wind travels slower, close to the ground, and then faster higher up. Now, Alex estimated that the wind speed at the propeller might be 10 or 15% higher than at the telltale. So it's possible that the car could be moving slower than the wind at the propeller, and yet appear to be moving faster than the wind at the height of the telltale.
Now, I think that this is a small effect. However, in combination with the previous effect, it just can make this more frequent. Okay, and that completes.
Yeah. If I remember the video correctly, Derek reports that they've achieved up to 2.8 times wind speed. That feels much higher than what is possible here, unless the wind had picked up and then spontaneously sort of dropped.
Very, very good question. Okay, if you're going for the record, you probably will do many attempts. You will be sampling that gusty wind over and over and over until you set the record, right? That's how you set the record. And on one of those occasions, you will get a nice strong gust, which is 3 times the ebb that comes after it, okay? And that's when you will clock the record, and that's where that 2.8 factor will come in.
So what about the treadmill tests? These are conducted in still air. By moving the ground backwards, you're simulating a perfectly steady tailwind. And if you hold the car stationary on the treadmill, well, that's equivalent to the car going exactly wind speed. Now, if the car can move forward on the treadmill, that shows it can accelerate faster than the wind. But Alex had multiple explanations why these experiments don't actually show what they claim to show.
If you have this fluctuating speed of the treadmill, and then if a human just sort of steers it, it then can introduce unconsciously a bias towards the desired result.
So would it may be that the guy with the spork is inducing the model craft to go across the wind now and then?
So
and as you pointed out, Alex, it's going downhill now and then.
Yeah, I'm 100% sure that the guy in the video doesn't do it on purpose. Okay?
Yeah.
However, yeah, if he is expecting forward drift.
Yeah. Oh, it's classic.
Right? Yeah, absolutely. Yeah, that's what exactly. Okay, so you got it.
In the absence of convincing experimental evidence, Alex turned to theoretical analyses, like one by MIT Aero professor Mark Drella. But here too he found problems. His main concern is that the equation for net force includes the difference between the speeds of the car and the wind in the denominator, which seems to imply that when traveling exactly wind speed, you should get infinite force.
Now here's the real danger. Because if Derek drives very close to the wind, that difference in speed goes to zero. If it's 1/1,000,000th of a 1%, that's like a nuclear bomb exploding behind him. Then Derek is definitely in trouble, right? So we need to find something to save Derek's life here. This is serious, right?
But dividing by zero, come on.
It keeps on going, but I'm curious, what did you see? What did you notice on both sides, the way that he's narrating this and what the professor is actually saying? What do you see? What kind of statements come up that seem very, very strong? 100% sure. What is he 100% sure of? That the person is not doing this on purpose, right? That he's somehow unconsciously inducing the effect by, so he wants to find the effect. Therefore, he's doing something that he does not notice in order to cause the effect. And it's possible, there's no other possibility. Is 100% sure that this is done subconsciously, that he is inducing the effect. Anything else comes up? What else did you notice? Famous people making sure that everybody is showing their best evidence, right? Really big celebrities. I don't know if you're familiar with these two people, but it's not easy to get these two on the same Zoom call. They're science communicators. One of them is a very famous professor. The other is a very famous science communicator. And both of them trust the two sides. The YouTube communicator seems like he's had some background showing that he's he's got good science skills. And then, of course, you've got a UCLA professor. What else did you notice? Seems like there's a theoretical account showing the impossibility that this actually works. There's something in these equations that none of us understand, right? That makes this completely impossible, right? Now, they bet $10,000 on this, right? What do you think about this solution? Would you be able to bet $10,000 on any of your research? How about this as a solution to resolving scientific debates? No? You need to really believe in what you think in order to put that sum of money. And he's not using his grant money. He's using his own UCLA professor salary, the Veritasium. He's making good money from YouTube, but I don't think he has $10,000 to just give away, right? So already a very convincing demonstration on how much they're convinced that they're absolutely right. So this is kind of the setup. It's a public bet. Science celebrity observers to make sure that everything is solid. They hear both sides, and then they need to resolve this. What's the best way to resolve this? How do we know? Aside from the two observers saying, we believe this one, we believe that one, how do we resolve this? What should we do? Sorry? Just do it, just make it. Who should make it? Who should do it? The YouTuber already did this. He did a previous video where he showed this. But what the UCLA professor was claiming is that this demonstration and his proof is actually wrong.
Oh.
The whole thing started because the UCLA professor said that what's happening in the video actually does not show support for that.
Oh, and the professor should make it.
The professor should make it? Okay. Why wouldn't the professor make it before he invests $10,000 in this?
he wants it to be credible. Like he's very sure that if he I guess replicates this, it wouldn't work.
What I really like, and the statement that stands out to me the most, is what Veritasium was saying here. It's like, because if I am wrong, then I want to know. The reason why he's willing to bet 10,000 US dollars on this and do this publicly is because he believes in the scientific process. And despite all of these horrific case studies that all of you just witnessed, why am I still in academia? Why do I keep doing this? Why do I keep submitting, even I've been hurt again and again by each and every one of these peer reviews? Because it could be that I'm wrong. And if I'm wrong, I want to know. And I want to keep doing this because all of us as a community benefit from these kinds of debates. We are progressing towards better science overall as a community. And then we can do hackathons. We can reflect on the process. Was I wrong? Were they wrong? Should it be published? Should it not be published? So I really like the process. Like the whole point of the channel, the whole point of what we do as academics is to get to the truth. So I like the process of a debate as long as it's civil, of course, as long as it's not personal, as long as we can talk about things. And what I like about peer review, especially if it's open peer review, like in peer community, is that things are in the open and we can share them. We can talk about them in class. That's something that happens in science, but does not happen with other brainwashes of all sorts, right? So comparing this to some of the statements by the UCLA professor, so he explains the whole thing, the whole proof that the YouTuber did is experimenter unconscious bias. So they did not understand things, and what they thought that they were demonstrating, actually they caused it. It was not caused by the wind, it was caused by the experimenter. This is the first comment on the YouTube that led to the whole bet. I disagree, and then I had back and forth, and then how should we proceed? Am I expected to produce a critique of a critique of a critique? Or should we take it to a more scientific direction, such as physics paper to be published in a peer-reviewed journal? Interesting. And this is another statement. It can introduce bias unconsciously, a bias towards the desired result. So he's saying that this is what's happening. Yes, I'm sure, I'm 100% sure that the guy in the video does not do this on purpose. Okay. What was the result? The professor was wrong and the YouTuber was right, and I'm going to show this to you.
Does it work?
It totally works.
Amazing.
Oh my god, it's so good.
Her fourth version of the cart works spectacularly, and it was designed to be replicated by anyone using just a 3D printer and a simple list of materials. She explains how to build it with more details on the engineering process on a video over on her channel, so go check it out. Now, Professor Kosenko has now conceded the bet, and he transferred $10,000 to me. So I want to thank him for being a man of honor and changing his mind in light of the evidence I presented, which is really not easy to do, especially in a public debate like this one. Now, I do not want to keep the money. I want to invest it in science communication.
So it's quite amazing that if the UCLA professor just took a few moments and a few dollars with a 3D printer to sit down and just try this, he might have been able to do this without the whole debate. And I think aside from the $10,000, which is, like, it hurts, it's a little bit painful. I think what hurts the most is that UCLA professors, us in academia, we look down at YouTubers. We look down at scientific communication. It's like, they're not doing real science. We're the ones, we have our equations, we do real science. So I think it was painful and a really good lesson to do this publicly for UCLA, a really humbling experience overall. So there's lots of things that we need to take away from this about bias and about how to overcome bias. So a good way to do this is an adversarial collaboration where both sides have trustworthy judges. You have open science, so a full explanation. Have a third party, like this other YouTuber, just trying to do the model, just trying to repeat this again and again, and then making everything completely available to anybody who has a 3D printer and within $3 to $5 can print this and try this for themselves, seeing that there's actually no subconscious bias. You can just like see it going on a treadmill with no problem. Make sure that all the evidence is checked and evaluated and that it's reproducible. So I summarized my own takeaways here. So first, the professor could have tried this himself at any point for petty cash. Like, why would you not just try to replicate this? Like, why would you just like, let's do a peer review journal. Let's put $10,000. Like, what kind of hubris is this? It's really mind blowing, this whole thing. But it's also mind blowing to see the hubris that you just saw in your peer reviews, right? It's just unbelievable. It's like, why would you not take this as a compliment that somebody is trying to replicate your work? And whatever comes out, just say, this is good for science. Let's just go ahead with this. The professor assumed that somebody is biased in the videos, but never took a moment to think, maybe I'm the one that's biased. Maybe I'm the one that needs to rethink everything. And of course, confirmation bias is that whatever they see in the video, they think, oh yeah, this just shows that I'm right. Whatever they see, they cannot see this as evidence against them. So whatever they witness is just a confirmation of whatever it is that they believed before. So hubris, a bias against replications, a bias blind spot, seeing biases in others, but not recognizing that you have biases yourself, and a problem with confirmation bias. Most recently, I don't know, anybody watched Oppenheimer? So Oppenheimer is this beautiful movie. I don't know if you got to see this. Lots of amazing things there. Beautiful movie, thought-provoking and all of that. But there is one scene there, which is absolutely wonderful, where they hear that the Russians were able to do something that leads to nuclear fusion. So somebody comes with the news, and what does Oppenheimer say? He puts up the board, starts doing all the calculations, and say, I just showed that this is impossible. And then the practical scientist from the lab next door comes in and says, all this is good, but I just replicated their results. So just a mind-blowing moment that is based on a real thing that actually happened. So sometimes your science knowledge and your equations are quite limited, and sometimes you just need to try things out. How bad is confirmation bias? So we've actually tried to replicate this, and we found support for confirmation bias, and the effects are rather large. It's interesting to see this like again and again. Yeah, if you want to know more about just generally like cognitive biases in research, then Daniel Lakens, who we talked about a few times before, has a good book that came out and just finished a chapter about confirmation bias and us to needing to overcome this. Okay, intuitions about science. We have 4 different cards. A is like 3 and 8, and then on the other side, we've got like colors, and here we have a red and an orange. Each card has a number on one side and a patch of color on the other. You are asked to test the hypothesis that for these 4 cards, if an even number appears on one side, then the opposite side is red. Which cards would you turn over to test the hypothesis? So think about this. Look at the cards. You have a very clear hypothesis for the 4 cards. If an even number appears on one side, then the opposite side is red. What card should you turn in order to test this hypothesis? This is called a Wason's task. I'm just going to show you like this video here. It's also Veritasium, so just so you can see that he has like really good YouTube videos. And think about how this applies to our question.
I'm going to give you guys 3 numbers, a 3-number sequence, and I have a rule in mind that these 3 numbers obey. And I want you to try to figure out what that rule is. But the way that you can get information is by proposing your own set of 3 numbers, to which I will say, yes, that follows my rule, or no, it doesn't follow my rule, and then you can propose what you think the rule is. Is that fair?
Yeah.
Yeah, okay, so here are the 3 numbers, 2, 4, 8.
2, 4, 8.
You don't need to continue the sequence, you can propose a totally different sequence, whatever you want to propose, and I will simply say yes or no, that follows my rule.
2, 4, 8. 16, 32.
16, 32, and
64.
Yeah. Those also follow my rule.
Okay.
What's the rule? What are you thinking?
Multiply by 2.
That is not my rule.
What?
That's not my rule. But you're allowed, if you want, propose 3 other numbers.
3, 6, 12.
3, 6, 12.
3, 6, 12 follows my rule.
10, 20, 40.
10, 20, 40.
That follows the rule.
Yeah, I'm still multiplying by 2.
I know. I know what you're doing. And yes, it follows my rule, but no, it's not my rule.
5, 10.
10 and 20.
Follows my rule.
100.
200. 400.
Follows my rule.
500, 1,000, 2,000.
Follows my rule.
Want me to keep going?
But do I just keep going? You're going to tell me your rule?
Am I doing it the wrong way? Am I approaching this the wrong way?
You're totally fine,
Okay.
but you're approaching it the way most people approach it. Like, think strategically about this. You want information.
Yeah.
I have information. The point of the 3 numbers, right, is to allow you to figure out what the rule is.
Okay.
Okay, I'm going to give you the numbers that I don't think fits the sequence and then see what you say. So I'll say 2, 4, 7.
Fits my rule.
So whatever I propose is right?
So is your rule like you can propose any number? So the rule is anything we say is yes.
No.
Damn it.
But you are on the right track now. Hit me with 3 numbers.
3, 6, 9.
Follows my rule.
Oh, that didn't follow my rule.
This is good, right?
5, 10, 15.
That follows my rule.
What? Oh. Really?
Yeah.
I don't believe this.
1, 2, 3.
1, 2, 3.
Follows the rule.
What about 7, 8, 9?
Follows. Yes, that follows the rule.
8, 16, 39.
Fits the rule.
Excellent.
But we're no closer to the rule. I want you to get to the rule. How about 1, 7, 13? Follows the rule.
What?
11, 12, 13.
How does this
follows
make
the rule.
sense?
10,
I don't
9,
know how
8.
to do this.
Does not follow the rule. 10, 9, 8 does not.
Oh, so is it all in ascending order?
Booyah.
Okay.
Up top. Yes, first
that
ones
what
to
it
get
is?
it. You guys nailed it. That's the rule. That's the rule. Increase numbers in increasing order. Numbers in ascending order.
Oh, so much.
1, 2, 3, 4, 5, 6, 10, 15, 25. Doesn't matter. Any numbers in ascending order. I was inspired to make this video by the book The Black Swan by Nassim Taleb. Now, the black swan is a metaphor for the unknown and the unexpected. I mean, in the old world, the theory was that all swans were white. So each instance of a white swan would make you think, yeah, that theory's pretty good. But the point is, you can never prove a theory true. And in fact, when people found Australia, they realized that there were black swans. What was interesting for me was that everyone I spoke to came up with a rule very early on and then only proposed numbers that fit with that rule they were thinking. I was looking for you guys to propose a set of numbers that didn't follow your rule and didn't follow my rule. I was looking for you guys not to try to confirm what you believe. You're always asking something where you expect the answer to be yes, right? Like you're trying to get at it. Yeah.
But instead you want to get the no.
You want to get the no because that's much more informational for you than the yes. Like if everything's giving a yes.
True. That is
Yeah, so that's a basic tenet of Popperian science. So the usual response is really like B and C. It just like happened here. But C is definitely not critical. But D is the critical one because it has the potential to disconfirm the hypothesis. But we usually overlook that one, right? So it's an interesting task has been given to many around the world. So in a survey of 84 scientists, Mahoney in 1976 found fewer than 10% correctly identified the critical cards. And I think whenever we look at peer review, especially with replications, it's just mind-blowing how much confirmation bias there is there because people just want to confirm rather than try to reject. So just like a very interesting scientific like demonstration of this. And I love what Veritasium does. He takes a concept, he turns this to something else, and then he demonstrates this with different people. This is Dorothy Bishop. Did we talk about her before? No? Okay. So she's now retired. It was a big event for the open science community to thank her for her service because she did a lot of wonderful things for open science. But one of them is that she's one of the very few in the world to study cognitive biases in research and researchers. So we tell other people about their psychology, but we never reflect on our own psychology. So here is just like examples of some talks that she gave, like overcoming cognitive constraints to improve research, how scientists can stop fooling themselves, and the need to understand human psychology, fallibility in science, responding to errors in work. So I want to play a video to you by Dorothy Bishop. I think it's an extraordinary thing because Dorothy Bishop is the mother of cognitive biases in research. And this is one of the things, aside from her being just like lovely, things about confirmation bias in her own work.
I want to move on now to say something about confirmation bias, which you'll see how this comes into the position. It's another sort of cognitive characteristic of people, but if you put it together with p-hacking, you get into really serious trouble. But let's look at confirmation bias on its own first. So it's basically, it can operate at various points in the research cycle. I'm going to focus on an aspect of research that isn't much focused on, which is how we select other work to cite when we write our introductions to papers, for instance. And I think virtually everybody in this room who's ever written a paper will be in the position of knowing very well that what you do, typically, is exactly what is described in this wonderful little cartoon. You sort of think, well, there's two sides to this question. I'm going to really try and find some evidence. And you go onto Google and you go, Google, or you might, if you're a scientist, go onto Science Citation Index, but you go, blah, 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 and then you find a paper that says exactly what you want to hear, and you go, jackpot, you don't look any further. There you are, you've got what you want to cite. And again, we ought to probably feel bad about this because it's a very biasing sort of thing to do, but it's very much how we're wired up to think and not to go around. In fact, we would suffer from terrible information overload if we processed everything that's out there. So we're very much people who we're certainly not behaving like Popper would like us to behave, trying continually to disprove our hypotheses and our beliefs. Life would get very, very tiring if we did that. Instead, we tend to be looking for supportive evidence. Now, I want to sort of use myself as an example because, you know, it's very easy to point the finger at other people, but I think that because I'm saying these things are generally human things, I think I want to illustrate that even with the best will in the world, one does this. So here's a personal example of suppressed memory for relevant research when it doesn't fit. So one of the things I work on is children's language disorders, developmental language disorders. I'm very interested in genetic factors. So I've done twin studies on this, and I've given lectures on the genetic basis of developmental language disorders, where the main interest is in comparing in monozygotic, I don't know if I can get this thingy to work, no, never mind. The column saying MZ is the agreement between two members of a twin pair if they're monozygotic twins, as opposed to dizygotic twins. And the prediction from a genetic model is that identical monozygotic twins will be more similar to each other than dizygotic twins who have only 50% of their segregating genes in common. And here we have 3 studies, 2 from the States, 1 British one I did, coming to pretty similar conclusions, all quite small sample sizes, but these are hard kids to recruit, but pointing to really to quite a strong genetic influence on developmental language disorder. So I would go around giving this lecture saying, look, we've got all this evidence, it's a highly genetic condition, highly heritable. And then this study came along in 2005, and it looks completely different. So there's not really much evidence, well, there's no evidence for any genetic effect here, and indeed the agreement between 2 members of a twin pair is quite low. And I had found, I suddenly realized that although I had known about that study, when I was preparing talks and things, I just never thought to put it in. I sort of managed to mentally suppress its existence. And it was only when I had to do some more systematic review that I sort of came up against it again and thought, oh yeah, that's that study by my PhD student.
That was a study by her PhD student that she completely suppressed and forgot about because it did not go with what she was looking for. So that's the only study, a most recent study, 2005, but she forgot about because it did not go with the general story about the difference between these 2 types of twins. So if Dorothy Bishop, as a person who is studying cognitive biases in research, cannot even overcome this in order to not follow confirmation bias. I think, you can see the surprise on her face. You're just like, oh my gosh. So really a lovely story. I love it that she reflects on her own biases and she shares this with everybody else to show that actually it doesn't matter if you're the biggest expert on cognitive biases, you still have to find a way to not fool yourself. So this whole thing about cherry picking, we all do this, right? When we write our thesis, we just want to write the quickest introduction possible with all the great citations so that we can put this behind us. But this is not the way to do things. We need to do things a lot more systematically, and we need to look for evidence that disproves what it is that we believe in. I like this tweet. It's a very interesting tweet. I think most of us do in our peer review. New study released. Does the study validate my preconceived beliefs? Yes, must be a good study. I was right all along. I am a genius. No, must be a bad study. Find any flaws? Yes, bad study. I was right all along. I am a genius. So all of the peer reviews that you've just seen is kind of like in this direction, especially the one that we saw that's stage 1 review, just setting things in advance so that whatever the outcome is cannot really inform my prior beliefs, which is just remarkable, outstanding about how original authors just want to protect, rather than really pursuing the truth, just like want to protect their piece of scientific publication rather than knowing what's out there. So cherry picking in literature reviews is like a really serious problem. So consequences of all these omission errors is that we tend to trust the citations that support our views. We cite our supportive materials, but we never cite somebody who's like against us. Reading the prior literature doesn't really help you in this case. It doesn't debias you. If anything, it just like confirms whatever that you've held before. So the good thing is like just we discussed in the meta-analysis session that we had, to do this systematically, to pre-register everything in advance, to make sure that you're not fooling yourself and that you're seeking out ways to disconfirm what it is that you believe in. And of course, all the things about openness and transparency, and to invite criticism and adversarial collaborations, and to have other people check your work all the time. This is the way that we do things. We show others that we make mistakes. We invite them to attack us and help us do better. And then we congratulate them for when they find mistakes in our work. Bias blind spot, I think we talked about priming literature quite a lot. To me, it's just like baffling that people are still doing priming research. A lot of Francesca Gino's work is priming, and now we understand, how some people are able to find these from, fraud to questionable research practices. The reason why I'm bringing this back here again is because of this guy. I may have mentioned this to you, but Kahneman, in Thinking Fast and Slow, 2011, had a whole chapter about the priming literature. And then he had this very famous email that he sent to all the priming literature scholars saying, you must check yourself because I wrote this chapter in my book, and you have to make sure that this is really, really solid. And he said, count me in as a general believer. But if you don't fix this, then I see a real problem for the entire literature in priming effect in psychology. And then after a few years, when he realized that these things don't replicate and that they failed to clean up the literature, he said, there's a special irony in my mistake, because the first paper that he ever published was about the law of small numbers, which allows researchers to trust the results of underpowered studies and unreasonably small samples. So he did this in the 1960s, 70s, but I failed to internalize its message. And it's also nice to hear him reflect on this, on why you need more adversarial collaborations. And him also saying, there were essentially no takers for my suggestion that priming researchers should proactively replicate each other's work. And he was wrong. Well, I was wrong. At least in this case, the studies of behavioral priming that I had cited in that chapter were largely discredited in the famous replication crisis. So this is all great stuff. So he's reflecting on priming literature and all of that. But to me, when I saw all these things, and I have a lot of respect to Daniel Kahneman, he is a very humble, serious researcher, almost almost all of the stuff that we try to replicate from him, replicated successfully. But to me, this is an example of a bias blind spot. What is the bias blind spot here? The Kahneman is very easy, quick to see the bias in others. Priming literature, check yourself. But he never took a moment to consider the problems for himself. Is judgment decision-making solid or not? Turns out that it is solid, but he did not conduct a mass replication of his own studies. He did not call the judgment decision-making people or behavioral economics to check their own work. So it's very easy for us to see all the flaws in other people. When we're peer reviewers, science needs to be perfect. This is wrong, and this is wrong, and this is wrong, reject. But when you submit, of course, you know all the flaws, and you're just hoping that nobody else will judge you in the same criteria that you judge others. So if we just all accept that we're human and we have weaknesses, then we can be a lot more humble and accepting of issues. One of the first things that we replicated is actually the bias blind spot. It was an interesting demonstration. So you can see all the HKU students that are on this paper. And what was nice about this is that the British Psychological Society and a bunch of other media really liked it, summarizing our replication, saying good news for science, bad news for humanity. The bias blind spot just replicated. Everybody else is more biased than me bias. So it was just nice to see kind of support for the HKU students doing replications in my work. And since then, I've been demonstrating the bias blind spot again and again. First, I would show students in my classes, in my undergraduate classes, that they're biased. So for example, I would ask them, please rate yourself on dependability, on objectivity, on consideration for others, on snobbery, deceptiveness, and selfishness. And I would show them that based on their own rankings, they put themselves to be high on the positive things and low on the negative things. So of course, it's like the better than average kind of effect. And then I tell them about the better than average effect. And I tell them, this is what I would expect from this pattern. And then I ask them again. So even though I tell them about this and I tell them about the bias and I ask them, here's a list of biases like halo effect or self-serving tendency. Please rate yourself and rate HKU students. And then you can see that despite me telling them about all of these biases, they still rate themselves as being less biased than others. So my own self-serving tendency is lower than the average classmate self-serving tendency. So it just seems that even when we tell people about the bias blind spot, especially Kahneman and Dorothy Bishop, two big people who know about this, we still fall into this trap. So when we're peer reviewers, we tell the other, you're biased, you didn't do this, you should do more of that. But we don't, just like in the UCLA professor, stop for a second and think, is it possible that I'm not seeing something? Is there a way for me to test this better? Could just spend 5 minutes and $5 with a printer in order to check myself. But we can't, we continue again and again. We escalate this into $10,000 betting on public YouTube. So my question to Kahneman, and I've asked this publicly many times, is like, did you try and replicate your own work? Should we try and replicate JDM findings? Why is this different than social priming? How do you know? If you see biases in others, why don't you call for others to check biases in yourself? So the check me, replicate me is more than just a slogan. It's a way for us to protect ourselves against our own biases. Of course, we also replicated a bunch of other things like the better than average effect. Last thing that I think I want to mention to you is this very curious, and I think all of you saw this in the peer reviews that you've read. It's called self-interest is overestimated. We all think that the other person is doing what they're doing because they're self-interested. It's very easy to look at the reviews that you just read and say they're doing this because they're protecting their career. They're doing this because this is in their best self-interest. But it's not necessarily the case. So we also conducted this very interesting replication of self-interest is overestimated. So a bunch of HKU students. And then some of them are already proceeded. I think, at least 3 of them are already PhD students. So it's nice that they stayed in academia. And what we did here is that we just followed the original demonstration that did this with blood donations and with smoking policy. So basically, we asked people whether they think, there's two populations, smokers and non-smokers, and we think, do you think that smokers would support a policy banning smoking in public places? And people say, yeah, I support this policy, but smokers, of course, they wouldn't support this policy because they want to smoke everywhere, right? But then we also ask smokers, and then we see that the rates of support for banning smoking in public places is actually very similar for smokers and non-smokers. So we assume that smokers would want to increase their self-interest, but I think smokers now understand that they're, causing pain to other people, therefore they would want to minimize this. So actually, the difference that we have in our mind does not come into reality. Also with blood donations, we ask about paid and unpaid. What is the morality of being paid for a blood donation, where people would do this only because they want to get paid? If they're not paid, of course, the people wouldn't do this. But when we actually ask people, are you willing to donate blood, paid or unpaid? It's about similar degree. So you can see the overestimation. The more it is to the right, the more overestimation there is, both in blood donations and in smoking policy. It seems like we overestimate people's self-interest. So this is my kind of like summary of how to apply this to replications. So you saw a little bit of that in the peer review. So we've got two sides. We've got me on one side, I'm a replicator. I run a lot of replications. And we've got on the other side the original authors, who some of the responses you just seen. So original authors are like, they want to take me down more than they care about science. They want to fail the replications. I believe that this is successful. They don't want to cooperate with me. They think that they're better than me. And then there's just a lot of suspicion and hostility. And on our side, we also get very defensive. We don't understand why the original authors would put themselves higher than science. We think that original authors would want things to succeed, even if it's not the case. That people, original authors, think that the science is their science rather than our science. So we just keep accusing one another. So one of the reasons why I would meet with them in person to sit down and discuss this, just like in the case studies that I told you, is that I want us to overcome this. But even when we meet, even when we discuss things, even when we share, even when we open everything, including the pre-registration and stage 1 before the results, it still comes down to the kind of reviews that you've seen. People just like, I'm better, you're bad, you're not for science, you're against science, you're against me, and all of that. And it's not just with replicators. Obviously, I have the same problem as an open science scholar compared to a status quo that doesn't think that open science is very important. And once again, we find ourselves just like blaming one another and being very suspicious, thinking that the other person. Also, you'll go through this, but journal, the peer review process, when you submit your work, you'll always think that the reviewers are biased. You're not biased. The reviewers are biased. Whatever it is that they find in your work is because they want to reject you. They don't want to do real science. So it comes into play in all sorts of, it's not just replicators, it's not just like open science, but also you will do this regardless of whether you're a replicator or an open science person. You will find yourself in this position about you versus the reviewers or the editor. And I think it's generally just a good idea, despite everything that I shared with you and despite me feeling hurt by some of the peer review, is to say that I meet these people in conferences. I try to come and say hi, and despite all the things that we exchange in peer review, we try to just like overcome this and talk to each other like human beings, and to open things up and publish this at the end so that it will be a public debate, just like Veritasium and the UCLA professor. So there are solutions to all this. And at the end, the way that I see science is a little bit like this image. It's like we all need to help one another. The truth is out there, in the top, and we can't get to the truth unless we all support one another and overcome all of these biases. So if we maintain this, if you help your classmates to do better in their projects, not by hurting them, not by criticizing them, but by really giving them positive, constructive feedback to help them do better, and hopefully they'll do the same for you as well. So looking at this view of science rather than blaming one another and looking at each other as self-interest. So this is my kind of speech about the cognitive biases. And all this is to prepare you for the peer review that will happen next week after you submit. I'm very much looking forward to seeing what you've done. I hope that you find the process of replications fruitful and helpful for you to understand a little bit better. I think that being able to see somebody else's work and receiving some peer review would make this an even stronger process for you, more meaningful.